Hey students, I'll be discussing chapter 7 this afternoon. So I only have one question that I want to talk about. Chapter 7 is a little bit of a shorter chapter, but as you probably may have guessed by now, it's harder for me to be able to discuss formulas and numbers and such like that because it's difficult for me to be able to put it up on the board. So I always try to have more philosophical discussions about these chapters in quantitative methods. So one question I did want to say, and so chapter 7 I should tell you is on the logic of ordinary least squares estimation, OLS. Some of you may have heard that term before. We're going to get into that a little bit. Now, I want to talk about the question I want to speak about. So the textbook states that correlation is not causation. Some of you may have heard that before. I'm sure you probably have heard that. Correlation is not causation, but that covariation is essential to empirical hypothesis testing. How can OLS regression be used to build a credible causal argument even though it cannot prove causation on its own? What additional conditions or evidence would you need? Discuss what might be something you want to talk about if you were to answer the question, for example, in the discussion board or maybe an exam question. So let me begin by talking a little bit about that. Correlation is not causation. A term I'm sure people have heard about before. It means that just because two variables are related, it does not mean that one causes the other. However, OLS regression can still help build a stronger causal argument by showing how variables are related while also controlling for other factors that might influence the outcome. So the authors point out that although correlation is not causation, and it continues to be central in the social sciences, covariation is essential to the empirical test of hypotheses. The conventional method of examining this covariation is ordinary least squares, OLS, which I mentioned before, OLS regression, but this is accomplished under a wider theoretical basis rather than as a direct demonstration of causality. So if you're a researcher, you should combine the instruments of statistical estimation with the serious theoretical modeling and research design to construct a credible causal argument using OLS. OLS regression estimates the relationship between an independent variable and a dependent variable by fitting a linear model that minimizes the sum of squared residuals. In the stochastic specification, the coefficient captures the average change and associated with the 1 unit change n. This quantified covariation is essential because causal claims require evidence that variation in the independent variable is systematically associated with variation in the dependent variable. Without such empirical regularity, causal arguments lack support. However, OLS cannot demonstrate causation on its own since it does not ensure that the observed relationship is a true causal process. The existence of a credible causal argument demands more conditions than the covariation. The initial one is time ordering. The cause should come before the effect. In regression studies, this can frequently demand longitudinal data or assumptions having a theoretical basis on order of occurrence. An example would be that when x is measured after y, then any estimated relationship cannot be plausibly causal. Next is the condition of non-spuriousness, that is the association between x and y, not caused by the presence of any other variables. In OLS, omitted variable bias occurs when a relevant factor affects both x and y. To solve this, resulting in a false estimation. To solve this, researchers need to incorporate the right control variables, which are guided by theory, in order to isolate the independent effect of x. The causal claim, even at that time, is limited to the assumptions that all confounders have been controlled, and this is hardly ever the case with observational data. Third, there is the assumption regarding the error term. OLS is based on the assumptions that the error term is unrelated to the independent variable. Its variance is constant, and the error term is normally distributed. In case of the breach of such conditions, especially the independence one, the estimated coefficients can be biased and inconsistent. The point is that the error term should not be systematically dependent on x, is hence the focus of a causal interpretation. There are other types of evidence that reinforce causal claims on top of these formal conditions. Theory must be justified. Some plausible mechanism that connects X to Y should be stated. Only through robustness checks, including checking on other model specifications, can the results be judged to be sensitive to modeling choices. Stronger identification strategies are presented by natural experiments, instrumental variables, or randomized control trials as they approximate experimental conditions against endogeneity issues. Now, conclusively, OLS regression is an effective method of identifying and measuring covariation, which is an indispensable element of causal inference. Nonetheless, plausible causal arguments cannot be achieved without combining statistical data with theoretical arguments, specifying models correctly, and being attentive to assumptions and other plausible explanations. So, I understand that's a lot, and that's why I try to break up these chapters into more bite-sized pieces as I continuously make jokes. But I very much want students to take a little bit of knowledge from each chapter and be able to understand it well enough so that you can go someplace and you can have a conversation about it with anybody. Albert Einstein once said, if you don't understand it well enough, then you cannot explain it well enough. And that is the truth. If you don't really understand it well, you can't explain it. And that's okay. And that's why I want students to just take little bite-sized pieces. You don't have to devour the entire chapter. You can pick and choose some bite-sized pieces that are the most important ones for you for this course. Later down the road, if you want to explore more, by all means, you should do that. I hope that there was a little bit of knowledge sprinkled among all the gobbledygook that I just sprung out. And I look forward to seeing you guys again in Chapter 8. I want to thank you again for giving me your time. Thank you, and have a great rest of the day.